The Fokker 50 has an air conditioning and pressurization system to ensure a safe and comfortable environment is maintained for the passengers and crew. The air conditioning system is supplied by bleed air drawn from high pressure or low pressure compressors on each engine. Bleed air is drawn from the compressors on each engine through ducts located in the wing and dorsal fin of the aircraft into two identical air conditioning packs located at the aft of the fuselage. Pressurization of the aircraft is achieved by regulating the outflow of cabin air. The air conditioning packs are supplied by bleed air from the engines. Bleed air is supplied through ducts in each nacelle and wing, through the ducts located in the dorsal fin to a common duct in the rear fuselage. The common duct divides into two inlet ducts that feed bleed air into two identical air conditioning packs. The packs cool and temperature regulate the bleed air, then mix it with recirculated cabin air before distribution to the flight deck and passenger compartments. One air conditioning pack is sufficient for normal operation of the air conditioning system. The engine bleed pressure regulating shut-off valves control the air pressure for the air conditioning systems. With both packs operating, the pressure in the air conditioning system at sea level is about 24 psi. If only one air conditioning pack is operating, the bleed air system switches to the augmented mode, and there is an increase of approximately 30% in the system pressure. When the economy mode is activated, the regulated pressure in the system is decreased by approximately 30%. Each air conditioning pack is equipped with a pack shut-off valve. The pack shut-off valves are normally open, allowing air to pass into each air conditioning pack. The pack shut-off valves close to stop the supply of air to the respective air conditioning pack. The pack shut-off valves are closed when the pack push button is manually switched off, when there is insufficient upstream pressure, or when the pack overheats. Hot bleed air passes from the pack shut-off valves through the heat exchanger, where it is cooled by ram air from the rear fuselage. Bleed air passes to the dual temperature control valves located downstream of the heat exchanger. These valves open and close to direct the hot bleed air through the cooling system or through the hot bypass line. The temperature control of the supplied air is achieved by alternate operation of the temperature control valves. When one dual temperature valve opens, the second valve closes, thereby controlling the temperature of the supplied air. In the example shown in this schematic, the cold air temperature control valve is closed, causing the hot air to bypass the cooling system before being fed into the mixer. Note the cold air temperature control valves are normally in a half-open position. They are rarely fully open or fully closed. Recirculation fans, located beneath the floor in the aft section of the fuselage, draw air from beneath the cabin floor. The recirculated air is mixed with the temperature-controlled air in the mixer. The outlets of the two cooling packs are interconnected. A smaller diameter flight deck supply duct means that the flight deck receives 15%, and the passenger compartment receives 85% of the conditioned air. Using the information provided on the schematic, what would the air conditioning system provide? Normal air conditioning, reduced air conditioning for the flight deck only, or reduced air conditioning for the passenger compartment only? Please touch the highlighted area. Yes. A flight deck air supply duct passes below the passenger compartment floor to the flight deck. The supply duct branches into the ceiling outlets, eyeball outlets, and the flight deck heater. Air passing through the electrical heater is supplied to the side outlets, foot warmers, and to defog the windshields and direct vision windows. Ceiling vent handles located above the flight deck entrance can be opened to admit conditioned air via the ceiling outlet. The window demisting handle is located on the right-hand side panel. The handle is placed in the open position to allow conditioned air to demist the windows. The passenger compartment supply duct passes below the passenger compartment floor to two riser ducts on each side. The riser ducts join overhead distribution ducts behind the hat rack. Conditioned air flows into the passenger compartment from overhead air ducts and via the passenger panel through adjustable outlets. Conditioned air can be supplied to the cockpit and cabin from an external supply source. The ground connection is located at the lower right side at the rear of the fuselage. Access to the ground connection is through a shut-off door. The shut-off door handle is turned counterclockwise to release latches and the door is opened inwards. The fresh air valves are controlled by the fresh air valves push button on the ground air conditioning panel on the overhead panel. The push button is blank in normal operation, indicating that the valves are closed. When the push button is pressed, on is enunciated and the valves are selected to open. When the valves open, the open enunciation replaces the on enunciation. The cabin heater push button is also located on the ground air conditioning panel. In normal operation, the push button is blank and the heater is off. When the push button is manually selected on is enunciated and the heater is switched on. The air conditioning panel is located on the right side of the overhead panel. The panel incorporates controls for both air conditioning packs. Now examine the controls located on the air conditioning panel. The pack push buttons are used to switch an air conditioning system off. Touch both pack push buttons to confirm their location. That's right. The pack push buttons are used to manually switch an air conditioning system off by closing the respective pack shut-off valve. The push buttons are blank to indicate that the pack shut-off valves are open and the system is operating normally. Switch off the right-hand air conditioning pack. The off enunciation in the push button indicates that you have switched the system off and closed the pack shut-off valve. An amber false enunciation indicates that the pack shut-off valve has been automatically closed due to the pack overheating or low air pressure. The recirculation push buttons control the fans that supply cabin air to the mixer in the air conditioning pack. Locate the left recirculation fan push button to confirm its position. The off enunciation in the push button indicates that you have manually switched the recirculation fan off. An amber false enunciation indicates that the recirculation fan has failed. When the flight deck shut-off valve is closed, the corresponding fan is not activated if the push button is selected to on. Two independent selectors automatically maintain the temperature selected by the pilot. One selector controls the flight deck temperature, and the other selector controls the temperature of the passenger compartment. The temperature selectors provide automatic and manual control of the flight deck and passenger compartment's temperature control valves. Full clockwise rotation selects 27 degrees Celsius. Full anti-clockwise rotation selects 15 degrees Celsius for the compartment. The temperature is maintained at 21 degrees Celsius when the selector is set to a vertical position. The temperature selector is rotated to the off position to cancel automatic mode and enable manual control of the flight deck or cabin temperature. With the selector in the off position, cold or hot air can be supplied to the flight deck or cabin according to requirements by momentarily selecting hot or cold. The switch is spring-loaded to the off position when it is released, and the position of the temperature control valve is maintained. The temperature of the passenger compartment is displayed when the selector points to the 12 o'clock position. The display selector is rotated anti-clockwise to display the temperature of the flight deck supply duct. The display selector is rotated clockwise to display the temperature of the passenger compartment supply duct. The temperatures in the supply ducts are at variance to the compartment. They are lower when cooling, as shown here, but higher when heating is in progress. The flight deck heater push button is located to the left of the display selector. The flight deck heater is available at all times. The push button is normally blank, indicating that the heater is off. A white on annunciator is illuminated when the push button is pressed, indicating that the flight deck heater is selected. The temperature selectors on the aircraft control the temperature of the flight deck and passenger compartment via the temperature control valves. In automatic mode, the temperature control valves open and close to maintain the temperature selected at the temperature selector. Touch the selector to increase temperature in the passenger compartment. Observe the air conditioning schematic. The temperature display indicates that the cabin temperature has increased. The hot air valve will open and the cold air valve will close to regulate the temperature. When the automatic mode of temperature control does not control the temperature satisfactorily, manual mode is selected. Select manual mode for the cabin. In this example, the temperature control selector has been held in the cold position. The cold air valve supplying the cooling pack has opened, and the hot air valve in the hot air bypass duct has closed. When the temperature selector is released from the cold position, it springs back to the off position. The temperature control valves stop moving and the cabin temperature stabilizes, provided the flight level has not changed. The spring-loaded temperature selector is held in the cold or hot position for approximately 5 seconds, and the supply duct temperature is monitored on the temperature display. If the desired cabin temperature is not achieved within a few minutes, repeat the procedure until the desired temperature is obtained. 2 manually operated fresh air scoops are installed to provide ventilation during non-pressurized flight. Each scoop is located beneath each sliding window. The fresh air scoops are used during a non-pressurized flight. If a single air conditioning pack fails, a level 1 alert is presented, and the amber fault annunciation on the pack push button indicates that the pack shut-off valve has closed. A single pack is sufficient for normal operation of the air conditioning and pressurization systems. Additional flight deck heating is available electrically via the air-to-floor outlets, sidewall outlets, and window demisters. Switch on the flight deck heating. The status of the flight deck heating system is annunciated by the white on indicator in the push button. If both air conditioning packs fail, a level 2 alert is presented, and an amber fault annunciation is presented in both pack push buttons. Airflow into the aircraft will cease. If either recirculation fan fails in the air conditioning packs, a level 1 alert is presented, and an amber fault annunciation is presented in the recirculation fan push button. A recirculation fan failure results in a reduced airflow through the passenger compartment and flight deck air outlets. The Fokker 50 is equipped with two independent air conditioning packs which provide temperature-regulated air for the flight deck and passenger compartments. Air drawn from the bleed air system is mixed with recirculated cabin air to provide conditioned air for the cabin and flight deck. The air temperature from the air conditioning packs is automatically regulated. One air conditioning pack is sufficient for all air conditioning and pressurization requirements. The flight deck, passenger, and cargo compartments are pressurized in the Fokker 50. Pressurization is achieved by automatically controlling the outflow of conditioned air. A cabin pressure controller controls two outflow valves located on the aft pressure bulkhead. The outflow valves close and open to increase or decrease the pressure of the cabin and flight compartment. The pressure controller ensures that the pressure level in the aircraft and the rate the pressure changes is comfortable for the passengers, and that the pressure maintained is within the structural limits of the aircraft. The pressure controller computes the cabin altitude based on the aircraft altitude and the landing field altitude. The Fokker 50 pressurization system can also be operated in manual mode. In manual mode, the pilot controls the outflow valves through the pneumatic controls on the cabin pressurization panel. The maximum cabin differential pressure in automatic mode is 5.45 psi, which keeps the flight deck and passenger compartment altitude to a limit of 8,000 feet at an aircraft altitude of 25,000 feet. The automatic pressurization controls on the flight deck consist of the landing altitude selector, the barometric selector, and the rate limit selector. The landing altitude rotary selector is used to set the altitude of the destination airport landing field when the pressurization system is operating in automatic mode. The altitude of the landing field is displayed on the landing altitude indicator. The barometric selector is used to set the barometric pressure of the destination airport landing field in millibars. The barometric selection is indicated on the baro scale. The rate limit selector is rotated clockwise to increase the cabin altitude climb rate limit while operating in automatic mode of pressurization. Rotating the control anti-clockwise decreases the cabin altitude rate while operating in automatic mode. When the selector is aligned with the datum mark, the permitted climb rate is 555 feet per minute, and the permitted descent rate is 350 feet per minute. The cabin rate of change is indicated on the cabin rate cabin altitude differential pressure indicator. The automatic pressurization controller computes the pressure of the flight deck and passenger compartment by receiving inputs from the ground flight relay to determine if the aircraft is flying or on the ground, the takeoff relays, which provide power lever position, the static pressure, which provides the aircraft altitude, and the cabin pressure, which provides cabin altitude. Using data from the inputs, the automatic pressure controller opens or closes the outflow valves to control the cabin pressure. 3 pointers in the cabin rate cabin altitude differential pressure indicator display the following information: the rate at which the cabin altitude changes in thousands of feet per minute, the cabin altitude in thousands of feet, the differential pressure in pounds per square inch between the cabin and the ambient pressure. If the automatic pressurization system fails, manual control is available. The manual pressurization controls are located on the right of the pressurization panel. Manual pressurization controls and indicators consist of the pressurization control push button, the manual pressure control lever, and the manual rate control knob. When the system is operating in automatic mode, the push button is blank. An amber fault annunciation is presented if a fault develops in the automatic control system. The pressurization control push button is used to cancel automatic mode of pressurization and switch on manual mode. When manual mode is selected, a white MAN annunciation is illuminated. The manual pressure control lever is moved to the up position to open the outflow valves and increase the cabin altitude, and to the down position to close the outflow valves and decrease the cabin altitude. When the lever is in the central position, a steady cabin altitude is maintained. The manual rate control is used in manual mode. Rotating the manual rate control clockwise increases the rate at which the cabin altitude changes. Rotating the control anti-clockwise decreases the rate at which the cabin altitude changes. The cabin pressurization controller provides automatic operation of the aircraft pressurization system in ground mode, pre-pressure mode, takeoff abort mode, climb mode, cruise mode, descent mode, and landing mode. The cabin pressure controller is powered by 28 volts DC. The controller is engaged when the cabin pressurization push button is pressed in. The controller immediately examines inputs from the ground flight relay and the takeoff relay. The pressure controller performs a system integrity test if the power levers on the aircraft are in the idle position and the aircraft is on the ground. The system integrity test makes sure the system can operate automatically. If a fault is found, a Level 2 alert is presented and the pressurization system is switched from automatic to manual mode of operation. The pressurization controller puts the system into ground mode when the system integrity test is successfully completed. The controller signals the outflow valves to stay open and prevent pressurization of the aircraft when in ground mode and the power levers are below the takeoff position. The cabin to ambient air differential pressure is less than 0.035 psi. At sea level, the cabin altitude is minus 70 feet. Ground mode of pressurization is maintained until the power levers are moved to the takeoff position. The controller puts the pressurization system into the pre-pressure mode when the power levers are moved to the takeoff position. The controller signals the outflow valves to close until cabin altitude is approximately 130 feet below the cabin altitude at ground mode. The controller uses the landing field altitude, the barometric pressure of the destination landing field, and the rate of change. The rate limit selector is used to set the maximum desired rate of change of the cabin altitude. Set the rate limit selector to the datum position. Please touch the highlighted area. The landing altitude selector is set to the landing field altitude. Set the landing altitude to 200 feet. The barometric selector is set to the QNH barometric pressure of the destination airport. Set, that's right. The automatic pressurization controller issues commands to the outflow valves based on the information you have entered. After takeoff, cabin pressurization is in accordance with a climb schedule, where there is a cabin altitude for each aircraft altitude. To recap, consider you are departing from an airport at sea level. What cabin altitude would the pressure controller select in pre-pressure mode? Please touch the highlighted area. Yes. The pre-pressure mode continues until the power levers are moved back to the idle position, or the ground flight switch operates, indicating that the aircraft has taken off. If the takeoff is aborted and the power levers are moved back to the idle position, the cabin altitude is increased at the selected rate for 20 seconds to the altitude before the power levers were moved to the takeoff position. After a further 20 seconds, the controller puts the system into ground mode. The outflow valves are opened fully and the aircraft is depressurized. When the aircraft takes off, the ground flight relay signals the aircraft is in flight. The controller puts the system into the climb mode of control. In the climb mode, the climb schedule is used for the automatic control of the cabin altitude. To determine the correct pressurization schedule, the controller looks at the cabin altitude, the barometric pressure, and the rate of change. For each aircraft altitude, there is a scheduled cabin altitude. For each aircraft climb rate, there is a scheduled cabin climb rate. The landing field altitude is compared with the climb pressure schedule altitude. The controller selects the higher pressure altitude of the two as a control point. In this example, the destination field elevation is above departure field elevation. The taking off elevation is sea level, and the selected landing field elevation is 1,000 feet. The controller compares the scheduled cabin altitude against the landing field altitude and selects the higher of the two as a control point. In this example, the higher altitude entered is the landing field elevation of 1,000 feet. The controller signals to the outflow valves to increase the cabin altitude at the selected rate of 550 feet per minute to the landing field altitude. The controller keeps the cabin altitude at the destination landing field altitude until the climb schedule altitude is above the landing field altitude. Using this example, approximately how long is it before the cabin altitude of the landing field is established? Yes. When the aircraft climbs to an altitude where the scheduled cabin altitude is greater than the selected landing field altitude, the cabin climbs in accordance with the climb schedule at the scheduled rate. When the aircraft has maintained the altitude for at least 1 minute, the controller puts the pressure control system in cruise mode and replaces the climb schedule with the descent schedule to control the cabin altitude. The controller sends signals to the outflow valves to decrease the cabin altitude. Cabin altitude decreases at the selected rate of 350 feet per minute until it reaches the descent schedule altitude, where the differential pressure between the cruise altitude and the cabin altitude is 5.45 psi. The controller maintains this cabin altitude until the aircraft climbs or descends from the cruise altitude. The controller monitors and compares the selected landing field altitude with the descent schedule altitude, and maintains the higher pressure altitude of the two as the desired cabin altitude. Using the information supplied on the cabin altitude auto-scheduling graph, what is the cabin altitude when the aircraft has maintained cruise altitude of 14,000 feet for 5 minutes? That's right. When the aircraft makes a descent from the cruise altitude, the controller signals the outflow valves to decrease the cabin altitude. The cabin altitude decreases on the descent schedule at the selected rate until it gets to the landing field altitude, where it is maintained. When the aircraft lands, the ground flight relay energizes and a signal is sent from the relay to the controller to activate ground mode. If the aircraft lands with cabin altitude below the destination altitude, the cabin altitude climbs at the selected rate for a maximum of 1 minute until it reaches the destination field altitude. After 60 seconds, the controller puts the pressurization system in ground mode. The controller puts the pressurization system into pre-pressure mode if the power levers are moved forward during the depressurization period. There are 3 additional scenarios that may occur. Taking off with a selected landing field elevation below the takeoff field elevation, descending before the aircraft has maintained a cruise mode for less than 1 minute, and a step climb after the maximum pressure differential has been reached. First, consider taking off with a selected landing field elevation below the takeoff field elevation. In this example, the selected landing field elevation is 4,000 feet, and the climb schedule altitude is less than the takeoff field elevation of 5,000 feet. The pressure controller signals the outflow valves to decrease cabin altitude at a dwell rate of 175 feet, which is half the selected rate of 350 feet per minute, until it meets the landing field altitude or the climb schedule altitude. When the landing field altitude or the climb schedule altitude has been achieved, the dwell descent rate is stopped. As the aircraft altitude increases, the cabin altitude is increased in accordance with the climb schedule. Now, consider what happens when the aircraft descends without maintaining cruise altitude for 1 minute. The cabin altitude decreases at the dwell rate of 175 feet per minute, that is half the selected rate, until the aircraft altitude has decreased 1,000 feet. The cabin altitude then decreases according to the descent schedule at the selected rate, until the cabin altitude reaches the landing field altitude, where it is maintained. This example illustrates a situation where the aircraft has leveled off at a particular altitude, and this has resulted in the automatic controller decreasing the cabin rate to produce a maximum differential pressure of 5.45 psi. If the aircraft now resumes its climb, the cabin rate must climb at the same rate in order to maintain the maximum differential pressure. There are two outflow valves located on the rear pressure bulkhead that control the outflow of conditioned air from the pressurized area to the unpressurized area. Each outflow valve has a safety valve to keep the cabin to ambient pressure differential below the aircraft's structural limits. The safety valve acts if the pressure controller fails. The safety valve ensures the differential pressure is below 5.7 psi. The outflow valves are controlled by the pressure controller. The pressure controller gets static or atmospheric pressure from the static ports in the pitot-static system and pressure inputs from the cabin pressure sensors to control the operation of the outflow valves. The outflow safety valve pressure differential limit is set slightly higher than the pressure control limit. What is the outflow safety valve differential limit? Please touch the highlighted. That's right. Should the automatic pressure controller fail, an amber fault annunciation is presented on the push button together with a level 2 alert. If the automatic pressure controller fails, the control of the outflow valves reverts to manual mode, where the crew can maintain the cabin altitude at the level where failure occurred, or change the cabin altitude up or down at a selected rate. Although control of the outflow valves reverts to manual mode when the automatic mode fails, the pilot must press the pressurization control push button to achieve full manual control of the pressurization system. In this example, the amber fault annunciation indicates a pressurization control failure, and manual control of the pressurization system must be implemented. Select manual control of the pressurization system. The white MAN annunciation indicates that manual mode of operation is selected. The manual controls are the pressurization control push button, the manual pressure control lever, and the manual rate control knob. The manual pressure control lever is selected up to increase the cabin altitude. Increase the cabin altitude. When the pressurization control lever is moved to the up position, the cabin altitude increases. The cabin altitude decreases when the lever is moved to the down position. The cabin altitude is maintained when the lever is in the center position. The manual rate control knob controls the rate of cabin pressure change. Rotate the manual rate control to its fully decreased position. Please touch the highlighted area. The fully decreased position is the normal position during flight for the manual rate control knob. It is selected to this position during pre-flight. The pilot can switch from automatic mode of pressurization to manual mode if the pressurization system is operating normally. Pressing the pressurization control push button switches the modes. A white MAN annunciation is presented to confirm this action is successfully completed. If the pressurization controller push button presents the amber fault annunciation, indicating that the automatic mode of operation has failed, manual pressurization must be adopted. In this example, the pressurization control push button is presenting a fault annunciation. Take the corrective action. The white man annunciation on the push button indicates you have taken the correct action and switched the pressurization mode from automatic to manual. A cabin out annunciator, located on the central annunciator panel, is presented together with a level 3 alert if the cabin altitude exceeds 10,000 feet. The Fokker 50 is equipped with 2 independent air conditioning packs, which provide temperature-regulated air for the flight deck and passenger compartment. Air drawn from the bleed air system is mixed with recirculated cabin air to provide conditioned air for the cabin and flight deck. The air temperature from the air conditioning packs is automatically regulated. One air conditioning pack is sufficient for all air conditioning and pressurization requirements. In the Fokker 50, pressurization is achieved by automatically controlling the outflow of conditioned air. A cabin pressure controller controls 2 outflow valves located on the aft pressure bulkhead. The outflow valves open and close to decrease or increase the pressure of the cabin and flight compartment, and ensure the differential limits do not exceed 5.45 psi. The pressure controller ensures that the pressure level is optimum for the aircraft altitude and that the rate of pressure change is comfortable for the passengers. The Fokker 50 can also be operated in a manual mode in the event of an automatic pressurization controller failure. In manual mode, the pilot controls the outflow valves through the pneumatic controls on the cabin pressurization panel. The maximum cabin differential pressure during automatic mode is 5.45 psi, which keeps the flight deck and passenger compartment altitude to a limit of 8,000 feet at an aircraft altitude of 25,000 feet.